All right, so we're going to start off with a overview on the ASA, general ASA setup, configuration items. Again, if you have questions as we're going through things, feel free to type those in. If it's something that is pertinent, we'll call it out and address it at the time. Otherwise, you can take it offline and address it a little bit later. Starting off, again, looking at the exam hardware itself, yours in 8.x for the ASA itself. Different features of the ASA, different types of things that BI has to do. Stateful firewall, VPN termination. Do also have the other options for additional modules to be added in. At this point, not having additional modules for the scope of the lab exam at this point. Comparing to older versions, for those of you that have worked with the PIX versions, the PIX 6X and older versions generally seem to be a little bit awkward for some people working with. The newer version, more iOS-like, some other NAT options, different firewall, transparent option, virtual firewalls getting into context. Get into each of these in a little bit more detail a little bit later. Different features just were not available for those of you that were familiar with the earlier versions. You'd also add in the modular policy framework. Came in 7.0, but more and more features available in the 8.0 versions. Basically being able to have a structure similar to the MQC. For those of you that are familiar with the routers themselves, the MQC on the routers having a hierarchy structure, modular QoS CLI, class maps to match traffic, classify traffic, policy maps to act on the individual classes, and then being applied with a service policy. For the scope of the ASA, the older version of the PIX had what was called a fix-up command. So a fix-up command for a different protocol looking at specific items for those particular protocols. So say an earlier version of the PIX, one of the examples they had was the fix-up for SMTP. What the fix-up for SMTP did was rather than just allowing traffic as, okay, this is SMTP traffic, I'm permitting this through my firewall. Okay, yep, it must be fine. Be able to do deeper inspection, getting into deeper application inspection. With SMTP, for example, being specific to the certain SMTP message types as defined in the RFC. In this case, getting into the newer structure, doing the same sort of thing, but having it done with a class setup, with the class having an inspection, just having the inspect SMTP as part of a class, which could be a separate class or possibly the default class, which we'll get to in a little bit as well. In this case, just a different functionality. NAT control, we will talk about a little bit as well, a little bit later. The earlier versions for NAT, as far as NAT configuration, in the PIX version 6X and older, the NAT was required. I had to have a translation if I want to pass traffic from one interface to another, either a translation or a specific exemption. NAT 0, in newer versions, that is not a requirement. So NAT control, in addition to not being a requirement, that feature itself is currently disabled by default. So going back to our earlier topology picture, if I do have my firewall there, and I'm not doing a NAT translation, he will just pass that traffic through the firewall with the original source address. So depending on whether or not other networks have reachability for those particular networks, may cause problems with return traffic getting back. Transparent firewall, we'll get to it in a little bit as well. Transparent firewall itself acting as a layer 2 firewall. So instead of doing a layer 3 routed hop of the device itself, having different interfaces on different subnets, the transparent firewall having two interfaces on the same logical subnet. So two interfaces in the same layer 3 network. Firewall basically acting as a bridge, bridging those two VLANs together. Traffic passing from one to the other, passing through the firewall, and bridging that through. The end devices are not aware there's a firewall that's being passed through. But that can also get into other granularity, other restrictions as well. We also have the concept of virtual firewalls. Virtual firewalls themselves dealing with context. Context mode allowing the firewall itself to be split up into logical groupings. So we'll get to that in a little bit as well, but being able to take a firewall with a few interfaces, I could have, say, 4 interfaces, and I could say these two are in context A and these two are in context B, keeping those logically separated from each other. Get into some of the specifics on things you can and can't do with interfaces and things like that a little bit later. But just being able to logically separate things out could be for administration reasons, could be for security purposes, keeping things logically separated. General filtering logic. So general filtering on the ASA, on the devices themselves, traffic moving from a higher security level to a lower security level being inspected and tracked in the state table. So interfaces themselves being defined with security levels. So I have interfaces like inside and outside. DMZ are common interface names, types of names. And just because I have a certain name doesn't necessarily mean there's automatically a security level associated with that. If I just call my interface DMZ, it's not going to necessarily know how secure I think that interface is. In some environments, that may be fairly secure, and in some environments, that may be pretty close to being the outside. General types of things. Generally, the inside interface usually is going to have a security level of 100. Outside interface generally is going to have a security level of 0. So the inside being considered the most secure, the outside being considered the insecure, least secure interface. So in this case, looking at those numbers determining part of the traffic filtering itself. By default, allowing traffic to flow from a higher number, which is the higher security level, to a lower security level on itself. So if my inside is 100 and my outside is 0, if I don't have anything else configured, I don't have any access lists, by default, traffic able to pass from inside to outside because of the differing security levels. Now, in addition to that, as mentioned, it is tracked in the state table. So looking at information, looking at connections there as well. So I have a connection from the inside interface passing through the outside interface. That connection passes through my firewall. Keeping track of that connection, keeping an internal connection table, state table. When I have return traffic coming back, I can allow that traffic come back in. So in this case, the ASA is a stateful firewall keeping track of that state information. Now in our second case here, we have traffic moving from an interface with a lower security level to a higher security level. Can be permitted if there's an entry in that state table. So if it's return traffic coming back or something that was initiated on the inside, that return traffic being allowed to come back through the firewall. Now, if it's not return traffic, if it was traffic initiating from the outside, then I might need to get into other situations, things like possibly needing an ACL on the firewall itself for that interface to explicitly allow. By default, just looking at security levels, it goes from higher to lower, and keeping track of that state information for the return traffic. Again, things like ACLs can be used for exceptions. So going back to our earlier example with a VPN between two locations, if I have a firewall in the middle, if either side needs to be able to initiate that VPN, I would need to have that traffic permitted inbound on that outside interface in order for that router on the outside to be able to initiate that VPN connection. Now, in addition to these two, we also have a slightly different case, possibility of traffic between interfaces of the same security level. So in this case, I have 0 to 100 I can use. Possibility of picking the same level for multiple interfaces. Depending on the interface itself, most interfaces when defined are going to default to a security level of 0. So if I have, say, an inside interface and a DMZ interface, and those have both defaulted to 0, if I want to allow traffic, I have a separate command for that, the same security traffic command. If I don't have that command in, not going to allow that traffic regardless of any access list configuration or anything else on the device. In prior versions, this was used in some cases people would use for security measures. So if I had two people that I don't want to talk to each other, I could just put them in interfaces with the same security level so they're never going to be able to talk to each other. They could still talk to other parts of the network. But in this case, that traffic can be allowed to pass between. Now, with the same security option, we have two separate options for that. You could use one or both of those, have two separate commands. One is inter-interface and one is intra-interface. Okay, and the difference is inter and intra is whether it's on the same logical interface or different logical interfaces. So inter-interface being from one interface to another interface. So if I had Ethernet 0.1 to Ethernet 0.0, that would be inter-interface because it's from one interface to a separate logical interface. Now, intra-interface is if it is dealing with something that's on the same logical interface. If I had traffic from, say, Ethernet 0/0 to Ethernet 0/0, that would be intra-interface. And the reason why I say logical interface, it is possible to be dealing with sub-interfaces. So if I have something that has a physical interface being used, and I also have a sub-interface on that same interface, coming in a physical interface and leaving on a sub-interface are two separate logical interfaces, even though it's the same physical interface connection on the wire. One common situation looking at intra-interface on the same interface, also called hairpinning in some examples, could potentially be if I have a policy where I have VPN clients and my VPN clients are connecting. VPN clients are connecting in to my head-end device, and they're also using that location for internet access. Well, if that interface that they're coming in and terminating on is my outside interface, and that's also the interface that their internet traffic would be going out of, their traffic is coming in that interface, terminating, and then the web traffic, their web requests going out to the interface on the same logical interface. That would be one of the common real-world examples for where you might see intra-interface. There was a requirement in earlier versions that for the intra-interface, it would only do it for encrypted traffic. In newer versions, it will do it for any traffic that is being allowed to pass otherwise. Again, not an issue unless you happen to have two interfaces that are the same security level. For the scope of the lab, I would expect them to be fairly explicit as far as security levels, as far as what to use, what they're expecting you to use. Generally, for the lab, you don't want to make assumptions, but I would say it's fairly safe to say inside of 100 and outside of 0 is pretty common and pretty likely. Again, they could give you other things. Don't fall into any bad habits of always configuring things a certain way. Be aware that that's generally the way things are set up in most production environments. Again, it's just a number, it's just a numerical value, not a security vulnerability if someone knows what your interface security level number is. So the interfaces themselves, interfaces on the ASA itself, not pre-assigned names or security levels. Different things we need for the ASA, being able to configure the items, being able to set up and pass traffic. Everyone know what items we need on an interface in order to pass traffic? Short answer. We got some people typing in responses here. Again, the question was, what items do we need to pass traffic on the ASA interface? And some different answers here. Generally, a number of different things we need. It's not just one thing we need. Need to make sure you have addressing. For the most part, we'll talk starting about routed mode first. The standard routed mode having the addressing on the interface itself. Security levels. Security level needs to be defined so that the ASA knows how secure the interface is or isn't. And nameif. Nameif needs to be there. Interface labeled. If you don't have nameif configured on your interface, then you're not going to be able to pass traffic. Now, things like description. Some people do descriptions on the catalyst switches, things like that. For the most part, not required. Just additional information you can have if you'd like to. Some people like to go through and look at where devices are configured, looking at your physical connectivity. We'll have a separate diagram for your physical connectivity in the lab. Or ASAs, for example, are not directly plugged into other devices. They're most likely plugged directly into a switch. So you need to make sure you have VLAN connectivity from the ASA to the switch to that other device. And the most important one that I didn't see any answers on, but we'll throw out anyways, is the wonderful world of no shut. Make sure your interfaces are not shut down. If you miss that one, you will have lots of problems passing traffic. In the event you are doing something like sub-interfaces, make sure that you have your primary main physical interface not shut down. In the event of dealing with something like context, make sure your interfaces themselves are not shut down globally and that they're showing as up within the context itself. We'll come back to context a little bit more, as well as the transparent firewall. Just mentioned right now, transparent firewall a little bit different because you don't have each interface as a layer 3 interface. It's the same logical layer 3 network bridging between the two. So with a transparent firewall having an address configured globally, with the transparent firewall, if you do not have an address configured globally, again, not going to pass traffic, just doesn't happen to be on the interface in that case. We're dealing with context, the IP addressing itself done from within the context itself. In this case, slightly different in those other cases. So starting off with a general device, general configuration interfaces themselves. We're going to set up and configure some interfaces here. In this case, we have ASA2. We're setting up with a inside-outside interface connecting to router 3 and router 6, part of our diagram there. and we're going to take a look at the basic interface configuration on the firewalls. So starting off with our ASA, here we have a terminal window open. Can everyone see the terminal window okay? Text is clear enough? All right, so starting off, you may have a blank configuration. If you have a blank configuration just coming up, it may prompt you. It'll prompt here asking if you want to use the interactive prompts, the little internal setup. You can use that. Most people generally prefer not to. In this case, in case you do actually get into that, you can also just exit out. I'm going to go ahead and just do that. Control Z and exit out of that. Default enable password for a ASA firewall. Anyone know? In this case, our default password is blank, so do not have an existing password. So if you try typing Cisco, not going to let you in. Just do a blank carriage return, defaulting to a blank password here. So pulling back to our existing configuration here, take a peek at what we're configuring here. We have inside and outside interfaces connecting to our devices there, router 3 and router 6. Go ahead and start the configuration here. We have our inside Ethernet 1 connecting to router 6. /1. And on our interface itself, we have an address we're going to be giving it. In case an address of .9. /24 subnet. And again, the configuration looking blank, in this case wasn't quite completely blank. In this case, initially having a device here set for multiple context mode. Again, mentioned multiple context mode being a little bit different. In this case, it wouldn't allow us to put in our address. We're going to go ahead and change that. That will reboot the device. I'm going to go ahead and let that come back up. Again, just because the configuration looks blank doesn't necessarily mean that it is. Okay, just a minute to boot back up. All right, so starting off, we have our interfaces here. We have a name on this. Now with the interfaces themselves, name of inside is a special name. With that, taking that to a default of 100 for the security level. Again, also make sure you do a no shut, not shut down. By putting the name of inside, that did also set our security level. We don't need to explicitly set a security level. Go ahead and configure our interface. The outside defaulting, again, other names defaulting to 0 for security level. So because it defaults, that's the security level we want. We don't need to change anything with that. Again, make sure you do have the no shut as well. Looking at interfaces themselves, show interface. It does show up. It does show up for interface and line protocol. We'll check the Ethernet 01 as well. Inside showing up as well. Basic interfaces are up. At this point, we want to check basic connectivity. Change your host name as well, just to a little bit more clear. In this case, it happens to be ASA2. From the ASA, slightly different. You're able to do other commands from configure mode. And just put in regular commands here. On the routers or switches, would need to have the do command or exit back to just the pound prompt instead of the config prompt. But should be able to ping router 3 and router 6 at this point. And successful ping to router 3. Go ahead and verify that you can also ping router 6. Successful pinging to router 6 as well. So successful connectivity in both directions. In this case, just showing that ASA2 has connectivity to those devices. Now, just having connectivity to those devices doesn't necessarily mean that traffic will completely pass. In this case, router 6 and router 3 will need to have some sort of routing information if they want to pass traffic through the firewall itself. In addition to that, the ASA itself handles traffic differently when it's traffic passing to the device itself or if it's traffic passing through the device. So some of the different items configured on the ASA for traffic terminating on the ASA is different than traffic passing through the ASA. In this case, if I had an access list on my outside interface, and on that access list, I just had diagram here. If my access list on my outside interface, I just had a permit IP any, then router 3 would be able to initiate connections through router 6. It doesn't necessarily mean that connecting to ASA2, all those items would be permitted. The more common types of things, Telnet, SSH, miscellaneous management types items, those are restricted on the ASA itself. Do not need to be explicitly allowed in the access list for that traffic to pass. So slight differences in those and the way things are handled. One of those that comes up is the ICMP command. So looking at our options for ICMP command, we have permit, deny, and options for unreachable. Look at our ICMP permit options. You can permit by specific address, or you can permit by host, and you can also get into different message types. So I can say ICMP permit any echo and outside. And I could say ICMP permit any echo inside. Now what is this configuration going to do? I'm permitting echo on the inside and outside interface. Initially, if I don't have an ICMP permit or ICMP deny statement on any interface, I'm going to allow any ICMP traffic terminating to my device itself. If I try and ping my devices now, in this case, that same ping that I just tried earlier, in this case, not working, trying to ping router 3. If I switch over to router 3, router 3 is still able to successfully ping the ASA. Again, slight differences based on how things are configured. I'm going to just remove this one on the outside. And with that removed on the outside, I'm able to ping. In this case, this is individual. This is per interface. In this case, I had options for the inside and outside specified. I removed the one on the outside. In this case, without any ICMP statements on my interface itself, or the outside interface allowing any ICMP to that device. Now, if I just wanted to permit echo echo reply for ping, I could do that. If I just wanted to permit things like unreachables, I could do that as well. Be aware that you can get into other restrictions. Again, it's different than your access list restrictions for traffic transiting your ASA. We're going to get into some routing a little bit later, and after we get into routing, we'll talk about traffic passing through the device and having other traffic coming back. We got our basic setup here, basic configuration of our interfaces themselves. Take a look at our configuration here. Interface Ethernet 00, name outside, security level, IP address, 01, name if, security level address, 02, in this case, set as shutdown. We're going to go ahead and modify our configuration. In the newer versions on the ASA, the 8.0 and later, you do have additional options for interfaces. One of the other additional options that was brought in is called a redundant interface. So being able to have physical layer redundancy in the event that an interface fails. In this case, I can say if Ethernet 00 fails, I want Ethernet 02 to take over for that. In this case, I can configure that globally. I'm going to go ahead and just remove my configuration on my interface. And looking at our redundant interfaces, I did just choose one, but looking at those, we do have options for 1 to 8. So different options there. In this case, just going with my first one, redundant interface number 1. Now with that, I'm going to specify what's called my member interface. Member interface, we'll say ETH02, and member interface, ETH00. And go ahead and put our address back on there. And give it a name. And security levels set to 0 as well. And looking at our individual interfaces on the configuration again here. Individual interfaces, Ethernet 0, Ethernet 2. Again, not having information there, being pulled off to the logical interface of the redundant interface. We have a redundant interface specified. Member interfaces. Again, the redundant interface is our new logical interface. So we have name, security level, and address information. And looking at show interface, under our show interface here, again showing that that is a member of that redundant pair. So active member here is the 00. Ethernet 01, his properties, his address properties. Ethernet 02, in this case, Ethernet 02 is a standby member. However, if we look at this, we also see that Ethernet 02 showing as administratively down. In this case, when dealing with redundant interfaces, make sure you look at your member interfaces, make sure those are still not shut down. Looking back up here further at our configuration, Ethernet 02 is showing as shut down. It sounds like something basic, but I've seen a lot of people get screwed up by something that simple. Spend way too long trying to troubleshoot that. And then moving on farther down, our output, we do also have output for our redundant interface. Getting into our redundant interface, showing us what the address and information is, showing what our name is for that, as well as miscellaneous traffic statistics. Now, with a redundant interface, we do also see redundancy information. The different members we have, Ethernet 00, Ethernet 02, showing us that Ethernet 00 is active. Go ahead and take our Ethernet 02 and bring that one up. So we brought up our Ethernet 02 interface. Look at interface redundant 1 again now. Interface is up. Over to Ethernet 00. One down. Redundant interface still showing us up. In this case, it does show Ethernet 02 as our active member. Now, what happens if we try and ping? Will we be able to successfully ping router 3? So at this point, it looks like at this particular point, we're not able to ping router 3. We're going to take a quick look at our other settings here, see what other possible items could be. Someone did mention VLAN, so it is possible that that VLAN was not properly configured on our switch. Take a look at our switch. And in this particular case, our switch is nice enough to have descriptions that match up to what our interfaces are. In this case, we do have that present. For the scope of the actual lab, I would not necessarily expect to see that. I would say most likely you're just going to get a physical cabling diagram. The ASAs do not do CDP, so you're not going to get CDP information. In this case, our FA014 ASA 200 outside is in 39. However, our ASA2 Ethernet 02 is not in that same VLAN. If you are using redundant interfaces and are doing redundancy for that purpose, the underlying characteristics of the redundant interface needs to match on both of those. In case we're going to go ahead and just change that one over. Switch back to our ASA. Try that ping again. Okay, so our first ping didn't go through. Our second ping we got through at the end. What happened there? Does anyone know? Some other items going on here. Someone mentioned things like ARP. ARP, not quite what's going on here. Doesn't take quite that long. Getting into, someone also mentioned learning. Sort of, kind of. It gets into the spanning tree itself. So your spanning tree phases, blocking, listening, learning, and then forwarding. If you do just change a VLAN on a switch, it's not instantaneously going to change on your devices. So there is a delay on a switch when you originally have the port VLAN information there for that port being active and sending traffic. So in this case, if you just tried that first ping and then thought, oh my goodness, there must be something else wrong, it doesn't necessarily mean that. You may just need to give it time for those things to properly converge. As far as other items, anything we could have configured to prevent that delay? In this case, other spanning tree features, things like port fast, could prevent that delay from taking place or preventing that from kicking off there. Some people will go through and put port fast on all their switch ports connected to devices for the scope of the lab just to make sure that's not an issue. Other people just give it time to converge. Again, for the long term, they're not necessarily going to reload devices and have it immediately start sending traffic. They're going to give things a couple minutes for things to converge and routing protocols to converge. Just be aware that just because you're not initially able to send traffic doesn't necessarily mean that something else is broken. But in this case, I do have my interfaces up. Again, looking at my redundant interface, showing that's up. I have traffic input, output. It does show me what my redundancy is. Again, make sure to double check your switch information on your switch itself. Your switch information may be pre-configured, it may not. And in this case, we had one switch that was, one port was configured properly, the other port was not. So a task could tell you to take the information from Ethernet 00, move that to a redundant interface, and add in Ethernet 02 with that redundant interface. And if the task did do that and did tell you that, then you could have it configured properly on the ASA, but if you don't have the switch configured properly, your redundant interface is not going to work. Again, looking at our configuration items here, we configured our redundant interface. Member interface is listed there. A question came up, would they show the switch in the picture? As far as the picture, it depends on what picture you're looking at. Most likely you will have a physical cabling diagram and you will have a logical or IP addressing diagram. In this case, pulling back to our diagram that we have here. In this case, between router 3 and ASA2, this just says VLAN 39. So in order for that to be in VLAN 39, more than likely that's going to be router 3 is a port in VLAN 39, ASA2 port is in VLAN 39, and they have connectivity between those two. Now, for the scope of the lab, those devices may or may not be on the same switch. They could be on two separate switches, switch 1, switch 2. If that's the case, then you need to make sure to double check that there is a trunk configured between the switches, which there should be pre-configured, that is having either ISL or .1Q with that trunk configured between those devices, that VLAN 39 is defined on both sides and is allowed to pass across that trunk. Again, other types of things that could be put in there as a troubleshooting task if that was either configured to not allow that traffic or possibly if it was not set up on that device. So we looked at our interfaces here and looking at our show redundant. At the end, it does show us what our active member is as well as what our other member is. With the active member itself, the default, if both interfaces are up, is based on the order of configuration. So in this case, I have Ethernet 02 as my first one listed, then followed by Ethernet 00. So with the default, if both interfaces are up, that would default to interface 0/2. Now, you do also have the ability to manually switch over redundant interface, redundant 1, active member command. In this case, I can set it to Ethernet 00. Tells me my standby is down. In this case, I did not do a no shut back on my Ethernet 00. We're going to fix that real quick. In this case, it does show that we did switch over to the 00. So depending on what you're asked, you could be told to have the other interface as the active member. Look at your configuration order. Just because I changed it with a manual changeover, if I were to reload my device, it's still going to default to the order in the configuration. This case is going to have, based off what I have here, Ethernet 02 and then Ethernet 00. So different options, different features available with those. So again, redundant interface then becomes the logical interface. So you have your name, you have a security level addressing assigned to that redundant interface itself. Any other general questions on the redundant interface, basic interface, redundant interface setup? All right, so we're going to go ahead and move on to another device here. Moving on to configuration on our other device here. In this case, looking at configuration on ASA 1. So what's different with the configuration on ASA 1? Anything look different than what we did on ASA 2? So here we have more interfaces. We have 3 instead of 2. We also have the introduction of sub-interfaces. Slight differences there. Go ahead and get into these here. So on our device here, switching to ASA 1. Starting off, we have multiple interfaces. We have the outside interface as the Ethernet 00. We have a DMZ at Ethernet 0/1.10 and inside at Ethernet 0/1.125. And just configure those. Okay, now if we jump into the inside interface and we try and just configure a name, it's going to give us an error, so we need to have a VLAN configured. So because it is a sub-interface, we do need to have the VLAN configured for that. You can go ahead and specify a VLAN for that. The VLAN itself of 125, whatever you have for your diagram there. In this case, the sub-interface number happens to match the VLAN number. Does not have to be that way, but in a lot of cases it will match. Again, just choice. Some people prefer to use sub-interfaces .1, .2, .3. Some people prefer to use the VLAN number as the sub-interface number. So with a VLAN specified there, have VLAN information specified, and then going to go ahead and give it the name and addressing. So if you give it a name, give it an address, because it had the name of inside defaulting to a security level of 100. Did also mention here, in addition to sub-interfaces, the magical word of trunk, because we're pushing traffic for more than one VLAN on a single interface. It is going to be a trunk interface. In this case, having the VLAN specified so that the ASA is properly passing that traffic out. And configure our DMZ interface. On our DMZ interface, specifying our VLAN information. VLAN for that one as well. In this particular case, our diagram itself not specific or not telling us anything as far as what the security level should be for the interface. If you're not sure, double check first the section itself in your lab. Does your lab section, your diagram may not have it, but maybe in the section what your DMZ should be for security level. In this case, it does default to level 0 for other names. Inside will default to level 100. There are some cases, some of the syntax points, some places the ASA requires the name to be case sensitive, other places it doesn't. So if you do get in a situation, try and watch your case. There may be times it may reject your item if it had different case. In this case, I have the O capitalized on outside. There's some places that it doesn't like that I try and reference that with a lowercase o. Other places it will take it just fine and recognizes it properly. Just be aware of that. Also, double check if your lab workbook, for example, has it in all caps. Maybe you want to have it in all caps. So I've got my name, I've got my security level, I've got my VLAN specified here. Show interfaces, and what will I see? First line down isn't quite what I want to see. So starting off, it says we are administratively down. Again, make sure you get your interfaces no shut. Even when dealing with sub-interfaces, in this case Ethernet 01, because my main interface is admin down, my sub-interfaces are all going to show up as being down. Make sure those are straightened out. So we've got those brought up, they're not shut down. So our outside is showing us up. DMZ is showing us up. Traffic going there already. And inside showing as up as well. Next, we're going to go ahead and just verify quick connectivity here. Router 2 on the outside. Ping our AAA server on the DMZ. And able to ping router 5 on the inside. Again, if we wanted to get other restrictions, we could as well. At this point, we've got our basic interfaces configured, interfaces set up. And we're going to go ahead and take a short break here and then jump into some routing on the ASAs.